Hi, Joe. Hi, Jeremy.
Hello, how's it
Haven't,
going?
haven't seen you for a while. Today I prepare a short instruction, and first I would last week I talked with Jeremy, and Jeremy told me something about the hard drive, and I realized I haven't looked into hard drive or computer for a long time, and then I did a little reading. I realized, yes, Jeremy, you're right. You are using that NVMe hard
Yeah,
drive, which
yeah,
can do 3 gigabytes per second. Yeah, up to 3 giga, the highest speed. Uh, some can do 2 gigabytes per second read and write. So that's amazing. That's almost 10 times faster than the older SSD. So
yeah, and
that's
then it's just that small form too.
Yeah, that's very impressive. Also small form. Also, the connection is PCI Express instead of uh, SATA. SATA is the old interface for the hard drives. SATA 3 can do about 300 megabytes. So now with the PSI Express full lane PSI Express 3, full lane we can do 4 gigabytes. It's 10 times faster than the SATA. So that's a really exciting technology.
Is that 4 gigabytes a second?
Yes, 4 gigabyte second hard drive,
Jesus.
SSD hard drive. Yeah, 10 times faster than the old SSD. In my basement, I have a 10-year-old or even older computer. I have 3 SSD in parallel. Now, with this new NVMe SSD hard drive, literally we are talking about 10 of those in parallel, the speed.
Is that solid state?
Yeah, that's solid state. The newest computer use that type of hard drive, so the booting
Yeah.
up takes a second.
I have a solid state hard drive on my computer at home. I don't know how fast it is. It's been
That,
really reliable. I built it in 2014, and it's been great. It's
yeah,
still
that's generally about 200 megabytes or 100
okay.
megabytes. Yeah, but now we are talking about 2 gigabytes read
What's
and
the,
write.
what's the damage?
The damage.
Yeah, how much they cost?
Yeah, it's getting really lower, like $100 for 1 terabyte,
It's not bad at all.
like 13 cents per gigabyte. But if you buy from Apple, that's $1 per gigabyte.
Yeah, right.
All right, that's really exciting. This PCI Express bus. Another exciting news is also Jeremy told me about this Raspberry Pi computer module. Let me show you the computer module. The computer module is basically Raspberry Pi 4. Computer module 4 is basically Raspberry Pi 4 without all the IOs. So they have computer module for Pi 4. There's no IO, but it's $25. So it's $10 cheaper, but there's no IO. So it doesn't worth it actually. But this is a but. This computer module came with a I/O module. That I/O module really makes this a nice platform. Let me show you the I/O module. I/O module. So this I/O module has an actual component which really makes that computer module worth purchasing. Raspberry Pi CM4 I/O board. Okay, that's the I/O board. The I/O board, what makes I/O board so much better is it has extra connections. So you have 2 television connections right here. Everybody saw my shared, right?
Yeah.
You have network Ethernet, power over Ethernet. That's another thing. Ethernet cable can provide power. That's one advantage. Huge advantage is right here. If you look at here, what is this? This is PCI Express, 1 lane. Full lane is the full speed, can do 4 gigabytes. 1 lane can do 1 gigabytes. So this is a standard expansion card for PC. So if you have a PCI expansion card, it can plug into Raspberry Pi. Right in the middle is a Raspberry Pi 4 computing module. So altogether combined $25 plus $35. For $60, you can build yourself a little computer. More importantly, with a PCI Express 1 lane PCI Express expansion adapter plug-in, you can plug in an adapter. Any will work. So sound card, USB card, graphic card. Yes, there's a graphic. So you can have a low end, not the latest graphic cards. What's more exciting is the hard drive. The Nvme hard drive has a USB Express connections, plug in directly, actually. I actually saw a YouTuber in St. Louis. He actually vertically plugged in the hard drive, that super fast hard drive, vertically plugged in directly to this port, and got about 1 gigabytes per second of speed.
Wow, that's impressive.
Raspberry Pi. So Jeremy, now you're talking. 1 gigabytes of read and write speed on this new SSD hard drive.
Yeah, that's impressive.
Plug in directly. The only problem he encountered is you cannot boot. So far, the only support boot is from USB, from Ethernet, from SD card, not able to boot from this super fast hard drive. I would think after a couple of months, maybe later, that support will be added. And that means you can boot from SSD 1 gigabyte read and write speed SSD card hard drive. You can have 1 terabyte, 500 gigabytes, how many you want, and plug in here. Not all SSD works on here, plug in directly. Some don't work, so you just go online, do a Google search, watch this YouTuber. He make 1 model work. It's a Samsung SSD card. So yeah, $60 you can have a little supercomputer with 2 standard size HDMI connections. So this is a standard size television connectors. That's a little exciting. And then I will show this. This is a SSD hard drive came from my Apple computer. Because I was reading about SSD hard drives, I realized I can, because I'm using this Apple computer 10 years old, Apple Air, a MacBook Air, and I'm run out of hard drive speed. This guy is 128 gigabytes, 128 hard drive, SSD hard drive, original from Apple. I'm run out of space. I'm having so much pain. Then I realized I can buy a SSD hard drive. I bought a 1 terabyte. Arrived yesterday afternoon. I put it on. Now my Apple has a terabyte of SSD hard drive.
Oh wow.
Yeah, for $100. If you buy it from Apple, it will be $1,000. Like I said, 1 gigabyte per dollar. $1 per gigabyte. But if you buy from Amazon, because it's a general brand, so it's 10 cents per gigabyte. So now my Apple 10-year-old Apple computer have plenty of space. I did a benchmark on the speed. Its reading speed is 500 megabytes, write speed is 400 megabytes. The reason for that is the interface for this hard drive is SATA. SATA is the old interface. The maximum speed for SATA is 500 megabytes. So that means this hard drive I just put in has the maximum speed for that kind of interface, SATA. The newer computers have PSI Express interface for this hard drive, and that will be 10 times faster, almost, or 6 times faster. So reaching 3 gigabytes per second. So that's a little bit topic about hard drive. I thank you, Jeremy, and because you were talking about this, I realized I was not paying attention. So reading a little bit, it makes me almost want to buy a new PC or new Mac, because the latest Mac and the latest PC have this super fast SSD drive. And that's worth it, because it has been a long time for computer to have something exciting about, because I have 10-year-old computer. I see no reason to update. Now I'm thinking maybe I will buy a new one with this high-speed SSD hard drive, so everything can boot up almost instantly. All right, that's all I want to say first. Anybody? Jeremy, you have anything to say about your hard drive? What type of hard drive you bought?
Well, that case that I bought, it's only the SATA or SATA, so it's not compatible with the Nvme, but I wish it was. But yeah, I can only put the SATA.
Okay, that will limit your speed.
Yeah, like yours. So yeah.
Yeah. So I also see you have a USB adapter. You bought a USB adapter?
Oh yeah, that too, the enclosure.
Oh, okay. So you
Yeah.
can plug in.
Yeah, and it's bottleneck to the USB port, so you can't reach that the maximum speed or whatever, because it's only using that.
Yeah.
But it's still faster than a normal SSD though.
Yes, that's right. Well, you're limited by but if you use the USB 3, the Thunderbolt, I read the Thunderbolt can do 40 gigabits, so that means 4 gigabytes.
Oh, okay.
The Thunderbolt for the new Apples, the new Apple MacBook only has one plug-in port, that is a Thunderbolt or USB 3. So it can provide 100 watts of power deliver, and also has the 40 gigabits of speed.
Yeah, that would be nice.
Yeah. So 100 watts of power is a lot of power, because you can actually power a monitor just through that one connection. Data, high-speed data, and the power. So that's, I think Apple consider that will be the future because that's the only port available on the new Mac.
Which is crazy. I don't know. I don't know if I would like that, only having one port.
Yeah, people are complaining right now because they have to buy all kinds of adapters because they're still using the old TV, old whatever, everything's old. But then now they have this shiny new MacBook. There's no connection. The only connection is
Power.
power and Thunderbolt 3. Yeah,
Wow.
or USB 3, or USB 4. I don't know. They just call it different. All right. That's yeah. Basically, if you want high speed, you have to. You don't want a bottleneck. So if your hard drive is super fast, but your connection is slow, it will limit your speed. So any bottleneck will limit you as far as speed. All right, let's talk about the next topic I prepared. I actually spent some time working on this cluster. Cluster is a great idea, especially, for example, you have multiple computers sitting there. You can build a computer cluster with a high-speed Ethernet. So why do you need a cluster? Now, there are many reasons. Here are the two main reasons to build a cluster. Cluster, basically, if you have multiple computers, you have a cluster in your house. The first reason to have a cluster is the load balancing and the reliability. For example, if you are Google engineers, that google.com, that computer need to be super reliable. How do you make that computer super reliable? Build a cluster. So that cluster will provide a load balance. So they might have 1,000 computers behind that server. That 1,000 computer will balance the load. So millions and millions of people can do Google search same time. And it's also increased reliability. If one of those computers is dead, no problem, because the other computer will carry over the load. So that is for storage or for server. That's a big deal if you work in large companies. Storage, you want a reliable storage service. For example, if you are using Apple Cloud, iCloud, I use a little bit Apple iCloud. So that's storage. So cluster is behind all those services.
Can you change your camera? It's still showing the website. Thank you.
Yeah, make it bigger. Okay, it's bigger around, right? So that's one reason we have a cluster to have a reliable storage, reliable server. The second reason we have a cluster is for calculations. So if you do mathematical calculations, a lot of time you need calculate a lot of data. And if you have 10 computers cluster, then you can increase your speed 10 times because you are using 10 computers to do the calculation together. In order to have distributed computing, it's called distributed computing. This is right now the key component to make that distributed computing happen. Of course, you can always log on to 10 different computers and run 10 programs separately. Yeah, for example, if a certain calculation takes 10 days, you have 10 computers, you can do it in 1 day. But MPI means, but what if you have 100 computer, 1,000 computer? Then it became almost impossible for you to literally manually to log into each computer and start a calculation that way. So that's where MPI came to play. So MPI is this it's called messaging, or I forgot what it means, MPI. it's an interface. So it will be, it came with Python, it came with C, it came with Java. So MPI can work on all those programming environment. Which one is your favorite? That means you can write one program, you can execute one program from one machine, which may be called the master, and that master will send the work to all the workers. You can have 1,000 worker or 100 worker. That 100 worker will run that process parallel. So I watch a guy who is doing document processing. So for example, he can increase the speed. With one computer, he need, for example, 4 days. Now he have 6 computers. 6 computers each has 4 core. Every computer has 4 core, the CPU core, and he have 24 core. So if you run that process just using one computer, one core, it's 4 days. But if you use 6 computers, actually it's a very inexpensive little computer, identical. You can get a real bargain from because computers today are so inexpensive. So he has 24 cores. Instead of 4 days, using 24 core, 4 hours. So that's a huge, significant improvement for core. So MPI is the key. I also found a paper. Let me share the paper with you. And that paper is using Python MPI. So Python MPI. And it's a benchmark to show you the result, what the results of the improvements. Let me show the paper. So this paper is I downloaded from University of Montana. Montana. So in this paper, it shows the benchmarking results. It's a 2019 Montana Technological University. And he used MPI and a cluster of a bunch of computers, actually a cluster of Pis. So he used Raspberry Pi. Let me show the results. So he is doing parallel computing, and he used a Raspberry Pi. This is a computer identical to ours. And this is his components. 4 Raspberry Pi, Ethernet cable. When you do cluster computing, it will be, you need a wired Ethernet. You do not want to use Wi-Fi because Wi-Fi will slow you down. When you do cluster computing, those computers need a lot of bandwidth to talk to each other. So that's another thing, Ethernet. To make it even better, you want to use power over Ethernet. That means you do not have to power. You do not need to buy the USB power, USB cable. All those can be removed. Just Ethernet. But you need power over Ethernet. That's another way to do it. And so that's his method, Ethernet cable, 3 slaves, 1 master. So you have 3 workers, 1 master. The master is also a worker, so you have 4 workers. The only difference between master and the slave is master, we have the MPI coding is done in master. So that MPI coding is done on the masters. So MPI is the key of MPI programming, MPI and Python. So this is the MPI Python package. He downloaded MPI CH. So his program is done by Python. And let's look at his results. This is the math problem he's trying to solve. We will skip that. So this is the first results for benchmark results. This is using one core. If you see Raspberry Pi has 4 cores, so 1 core, 2 core, you cut the time half. 4 core, you cut time 25%. So 4 times faster if you use all 4 core of Raspberry Pi, Pi 3 in this case. So it will significantly increase speed. Generally, when you run a Python code, it only runs on 1 core. So now with MPI, you can deploy your math in all 4 of the core of the Raspberry Pi. By deploying all 4 core, you previously take 4 minutes, now it's only 1 minute. So you increase speed because you are deploying 4 core. That is one Raspberry Pi 4. How about multiple Raspberry Pi 4? He did another experiment. This is first he will run his math problem on 4 core inside one Raspberry Pi. Second experiment, he did his math on 1 core on 4 different Raspberry Pi. So you have 4 Raspberry Pi cluster, and the same math problem is deployed into 1 core on each Raspberry Pi. MPI can control that. So when you program in MPI, every core has a name, unique name. So you can deploy this problem into however you want to deploy. This is the way he deployed the problem. He found out their speed is identical. Their speed identical. You see here? This red line is the 1 Raspberry Pi. The blue line is the 4 Raspberry Pi. But it doesn't matter. The speed matches each other. Not much difference. This is one problem, the second problem, third problem, fourth problem. It turned out as the problem gets more and more complicated, 4 different Pi is faster than single Pi. Yeah, that's interesting. So this is a little bit faster. If a problem is simple, this is faster, A is faster. If problem is more complicated, the B is actually faster. It's maybe easy to understand because when the problem is getting more complicated, the network overhead, this is the network overhead because you have 4 Pi on the network overhead will delay your problem solving. So the 4 Pi will be slower. But if the problem gets more complicated, the network overhead becomes insignificant. And you're using 4 Pi, they are run cooler, colder temperature, they may run faster. That might be explains why method B is faster over here. Because the 4 separate computer runs faster, runs cooler. By running cooler, it will run faster. The last experiment is he will deploy the same math problem to all 16 core. Because you have 4 Raspberry Pi, 4 Pi cluster, he deployed all 16 core. And result is significant. 16 times faster, right here, shows right here. So this is the red one is a 4 core. If we use a 16 core, it's 25% of the time. Same math problem. This one, you have to have 4 minutes. And by having 16 core, this 4 core, By having thinking call, you only need 1 minute. So that is a cluster of Raspberry Pi or whatever computer you have. Potentially, if you do mathematical calculations, you can program in using MPI. By using MPI, you can deploy part of your math into one core, another part of math into another core, and balance the load, and increase your performance on a cluster of computers. So this is a cluster. And 2 applications of clusters. So that's pretty much all I want to talk for today. And if you guys have any comments, so if you don't have comments, I will turn off the recording.
Hey, what does NPI stand for?
MPI stands for, I forgot. Sorry, let's Google it. MPI means a messaging protocol interface. Let's Google it. MPI. For computers, this is almost like if you know the language, you talk like an expert. Yes, good question. So let's talk about MPI. But what is MPI?
So it's message passing interface.
Yeah, message passing interface. Meeting professional, international, or whatever. MPI. Yes, message passing interface. You are absolutely right. I did a Google search. That's my result. MPI. Yeah, that's what it is. Message passing interface. They basically it helps you to write your code on one computer and distribute the mathematical calculations on a cluster.
Okay.
You can control it. Treat every core separately. So if your cluster of computer is 6 computers, has a 4 core each, you can distribute into all 24 cores. If you're interested in MPI programming, I have a YouTube link, excellent YouTube link, very detailed instruction about MPI programming. So the C code did not run parallel by default. If you want your C code to run parallel or distributed in a cluster, you have to add an MPI interface to your original C code. And okay. Yeah, it works on Fortran, C, Java, Python, yeah, whatever your favorite programming platform is. Very good question, Tim. Anybody else?
You should Google Pi 400 specs.
Yeah, that's a new Pi.
Yeah, it is. Yeah, I saw that.
It's a keyboard.
Yeah.
Very nice. Yeah.
And it has a faster CPU now.
Instead of a
1.5, it's a 1.8 gigahertz.
Yes, because they have a better cooling inside. They overclocked it.
Yeah. So.
Yeah. How much? As far as it's $100, right?
I think so. Yeah.
Yeah, $100. Yeah. But it's a nice looking keyboard. You can show off. You know. Next time you're doing group project, everybody take out their laptop. You take out your keyboard.
Yeah, there you go. You just need a monitor now.
Yes, you will just amaze other people. Yeah.
When did this come out?
Just recently.
Just
It's like this week.
Just
Yeah.
this week, yes. I read the news. They sent out an email to my email address.
The
So
Magpie
yeah, Pi
magazine.
magazine or whatever. Yeah, 400. But I will not buy that fancy keyboard. I don't have a use. But I actually wanted to buy that computer module with I/O board because of this expansion card. If the boot up can be from that SSD hard drive, it's worth it. Now you have SSD hard drive booting.
Yeah, someone's gonna do it. Someone's gonna figure it out.
Yes, you're absolutely right. Jeremy, you are using a USB to boot up, right?
Yeah, I'll have to use a USB.
USB, yeah. Yeah, USB or Ethernet, gigabase Ethernet.
Oh yeah.
Yeah, I probably will buy a little enclosure if I see a cheaper enclosure and have a portable hard drive instead
Oh
of.
yeah, cause that's a spare one now, isn't it? Yeah.
Yeah, that's a spare from my computer. Yeah.
Yeah, just buy an enclosure.
Yeah, about the enclosure and but it's maybe not worth it because only 128 GB.
Oh, that's true. But still
Yeah.
like a backup.
Yeah, I can back up some pictures, for example. Yeah.
Yeah, there you go.
At least it's a SSD. I have maybe 7 or 8 SSD hard drive. But they are everywhere, all the places.
Oh wow.
My phone that was all slow ones, all 10, maybe 5 or 6 years old.
But with the enclosure, it'll be faster than a micro SD card, or
Yeah. All I need, also make it parallel. One way to make it faster for those hard drive is parallel. But with the Nvme, you don't need parallel already so fast. But you can also make it parallel. So instead of 3 gigabytes, if you parallel it, 3 of them, you can have 9 gigabytes per second.
Yeah, that's a lot.
Not enough. Talk to your kids. They were saying, oh, so slow. 20 years later, 20 years later, you said, oh, never heard of that kind of slow speed. 10 gigabytes?
Yeah. Well, it said the first NVMe SSD it came out in 2018.
Yeah, that's right. It's a couple years old. I never heard about it, but that's because I didn't pay attention. Yeah, it's several years old. Yeah. But
Yeah.
the price I noticed is going down significantly recently. So it's about 10 cents per gigabyte. Yeah. So no. Because all the computers in the old days, the bottleneck is a hard drive. The slowest components on your computer is a hard drive.
Oh yeah.
The old hard drives, they only can do like 50 megabytes or 70 megabytes. That's the old hard drive spins at 5,000 RPM. All right, I will see you guys Thursday, right? Yeah, everybody just make sure this we only have 2 weeks left, so no final exam. All we need is a final project and a final report.
I have a question.
Yes.
So they have this accessory I'm looking at for the Raspberry Pi called the Sense Hat,
Yes. Yes.
which that can monitor like temperature and stuff like that, right?
Yes, that's right.
So
Well,
instead, can you use that instead of like a PID controller?
yeah, you can build a PID controller based on Raspberry Pi. Yeah, it's a
Oh,
better computer. You can do
okay.
it, but you either find the existing PID controller code, or you write your own or modify it. Yes,
Okay.
all you need is a sensor, and then you need a Raspberry Pi to turn on the heater.
Okay.
Yeah. Then you can write a PID controller code. Actually, you can write a fancy, very fancy code because that Raspberry Pi is so powerful. Yeah,
Okay.
Tim. When you are there, last night, I actually read about all the adapter cards you can use on Raspberry Pi. Literally, there are thousands. A couple years ago, I see dozens, but last night I see thousands of potential cards, various sensors, motor drives, including my favorite motor drive. They all can plug into Raspberry Pi.
Okay.
Yeah, that's extremely exciting. $20. That's my favorite motor drive. You can drive full DC motor, full DC motor. So when I was looking at that, I was thinking, wow, I maybe just will build a long mower. The mower, Raspberry Pi based.
Yeah, you can do it.
Because it's motor drive, full motor drive, we can have a four-wheel drive vehicle. That four-wheel drive vehicle will drive in your backyard, you know. And then I have another control turn on a bigger motor with blades. That can be dangerous, cutting the grass.
Okay.
Yeah, and also has GPS modules. Like $20, you can have a GPS module and
Yeah,
Raspberry
and
Pi.
I saw this other thing called the PoE hat.
Yeah, there are so many hats. Like I said,
Put that on there, and then if you can power it up through your well, can you power it up through the Wi-Fi with that? It says allows you to power your Raspberry Pi using power over Ethernet enabled networks.
yeah, that's right. That's the one thing I like about it. I have yeah, if you use a power over Ethernet, you have to buy a special power over Ethernet switch.
Yeah.
Because the traditional Ethernet cable do not provide power. You have to have a special switch. And then you don't have to have USB power. You have the power will be provided by Ethernet cable.
Okay.
But that means you cannot use Wi-Fi. If you're not using Wi-Fi, then it's good. Ethernet cable then providing power. Yeah. Yeah, I found that the hat, there are literally hundreds, thousands of plug-in. So you can plug in here. There are hundreds of thousands of modules you can plug in here. This is the Pi 400. Yeah.
Like that Pi 400 though doesn't seem. It's not like you can't like make a robot with that or something.
Yeah, it's basically a desktop. Yeah.
Yeah.
It's
I guess because it's called a personal computer kit.
Yeah, that's right. It looks really nice. It just have a keyboard and.
Dang, they have this. Wow. They have a cluster hat.
Yeah, there's so many. Like I said,
The Pi Hut, and there's like, yeah, they have a lot.
yeah, they have a lot. Yeah, this is a TV hat. This is yeah, you have to have this hat to use the power over Ethernet. This is
They have their Arduino Uno to Raspberry Pi adapter. Wow, yeah, they have a lot of stuff on here.
yeah, the third party right now picking up. So they in this Pi system, yeah, they're anything you want. They make one of those.
I have a PWM controlled fan hat.
Yes. Your choice is almost unlimited. Yes.
I should have bought some of this stuff. What is the breakout?
A lot of those modules use serial connections, so SPI or I2C. Breakup, I don't know.
Breakout. That's just like the GPIO expansion cards, I guess. So you can add more stuff.
Yeah.
Yeah, that's what it looks like.
Yeah, I'm sharing a web page. You know, these are all the add-on cards you can plug into a Raspberry Pi.
What website is it? Oh, Pi Shop US. Yeah, I'm on a website called the Pi Hut, but I think it's a European.
Yeah, Pi Hut. Yeah. Actually, last night is Pi Hut. I was reading Pi Hut. I can't find a Pi Hut, but that's another. Yeah, all kinds of modules you can plug into the Pi. Even Halloween modules. I guess they have to discount that. Halloween modules.
Oh, yeah, there's a lot.
Yeah, if you buy that relay module, I see some of the relay module has 8 relays. That means you can control 8 appliances around your house. This one I like. You see this one? Cluster module.
Yep, I saw that one.
The Raspberry Pi 4, Raspberry Pi all plug in vertically. Yeah. Cluster module. Oh, Pi Zero. They are using Pi Zero, smaller Pi. All right, so many potentials, so many possibilities. I hope you guys excited. Not so much. Yeah. It's hard to get excited. You guys, everybody is spoiled. The technology.
Yeah.
Yeah, I can do this. It can do that. Yeah.